Good morning and good afternoon. So right now that we are going to be start with the AP Physics C mechanics part. So this is the FRQ that I'm going to start it. This is the first FRQ that I'm going to discuss it. So let's come to the screen. So let's continue. AP Physics C mechanics. This is the paper of the 2025 that we are going to be discussing. So first I request to you, please go through this FRQ and let's try from your side. So I will attach this PDF also in the description also. Please go through that first, give attempt from your side, then look into that and where you can improve that the things are or where you stuck in between. So let's read this FRQ. So there are the two blocks, A and the B, slide down each other in the horizontal surface, and the block 1 the mass m in the moving in the positive x direction. So the block 1 moving with the in the positive x direction, that is a v naught velocity, and the second block had the constant velocity, that the 2v, and the second block had the mass is 6m moving in the negative x direction, that is the block second that we have it, and with the constant speed in the figure one. The block then collide and stick together. So right now that you have to mark it. So the block collide and they stick together. Because they stick together, this is an inelastic collision, that is. So it doesn't have the kinetic energy conservation. Momentum is always conserved in elastic and as well as in inelastic collision. But in this case, the kinetic energy doesn't remain conserved. So it will convert to the some kind of the heat energy or sound energy. So, but you can always apply momentum conservation. There is no problem in that. So the question is, collide together from the time t is equal to 0 to tc. After the tc, they stick together and they start moving with the constant velocity as per the questions. Now, in the diagram, in the figure number 2, as used to represent the momentum of the block 1 and the before block 2 before the collision, the momentum of the vector diagram for the block 1 before the collision is as shown. So draw the arrows on the grid and represent the momentum of the vector of the block 2 and before the collision, and the two block of the system before and after the collision. And the arrow should be start from the start at the zero momentum line. The length of the arrow is proportional to the relative magnitude of that one. They represent the arrows of the zero length by drawing the dot 0. So the thing is, they're asking to draw the momentum of the block 1, block 2 after the collision happened. So what the momentum before the collision and after the collision that we have to figure it out. So they already given the momentum arrow for the first block. So let's see the first block, how much the momentum that the first one have. So the momentum of the first block initially, what the momentum is, it had a mass. Momentum is mass into velocity, mass into 2v naught. So basically, so the thing is, they're asking to draw the momentum of the block 1, block 2 after the collision happened. So what the momentum before the collision and after the collision that we had to figure it out. So they already given the momentum arrow for the first block. So let's see the first block, how much the momentum that the first one have it. So the momentum of the first block initially, what the momentum is, it had a mass. Momentum is mass into velocity, mass into 2v naught. So basically 2v naught is the momentum of that one. And they represented 2v naught with the 2, basically. They are the 2 marking over there. So up to the 2 marking, it is the 2m. So if I had to write the momentum for the first block initially, that is before the collision, that is the 2mv naught. So we had to keep proportional arrows only. So this is for 2mv naught. And let's calculate the momentum of the second block also. Momentum of the second block is mass into velocity. So the momentum of the block initially of the second block is 6mv naught, mass into velocity, and that is 6. So it is 6mv naught. So this is the momentum in the negative x direction. So because momentum is conserved, it doesn't matter it is elastic collision, inelastic collision. So the point here is you have to be add both of them. before the collision, the momentum is uh, -4 in this direction. So I just added both of them, -6 plus. So this is -4 mv naught. And now because momentum is conserved, so after the collision also I have to be make the arrows like that. That should be clear to you. So this is the momentum conservation, simple. Let's move to the second part of the question is, during the time 0 to Tc, the force F is exerted on the block 2 by the block 1. So we are talking about the force on 2 by the block 1. If they are going to be collide, let's suppose this is the block 1, block 2. So it is going to be apply some kind of the force on that, correct? So we are looking at that one only along the x direction as the function of this one. So they already given the function value. Since a is the positive constant, F maximum. So this is the magnitude of the maximum force exerted by the block 2 by the block 1 during the collision. So we have to be derive the expression for the F maximum expression, your answers in the term of mv naught and something. So these are the constant you can you have to be answer that. Okay. So the point is we had to be find out the maximum force. So this is the force value that they given. So now you had to be recall the force and the conservation of the momentum or something. We know the momentum, correct? So the point is the force and how the force and the momentum are related to each other. There is a Newton's second law. Newton's second law is F net force on the system is mass time acceleration. So mass acceleration is final velocity minus initial velocity by time. So then we have the mass into final velocity minus initial velocity. I'm just doing the derivation to show you, but it is not required. You do not have to be think about that in this direction. But I'm just showing that this is mass into final velocity, mass into initial velocity. This is the change. Mass into velocity is final momentum, and this is initial momentum. This is the change in the momentum of the force, that is the net force. And if I change it like this is the change in the momentum. Delta P is nothing but force, net force into delta T. And that is this quantity, the change in the momentum, our force into delta T, this is we call it impulse. This is we call it impulse. That I want that you should recall it for this, because the change in the momentum of the second block just after the collision, before the collision, we are going to be equate to the force into delta T, but the force is changing. So if the force is changing as the time is passing, so obviously we can't apply this formula. We had to be, this is a constant force. This is only for the constant. The force is changing. So what we need actually, we are going to be use the calculus for that. So the same stuff, but I'm going to write it. The change in the momentum means I'm going to find out the change in the momentum of the second block. Change in momentum of block B is equal to, I'm going to put the integration sign because the force is changing over there as the time is passing. So this is delta T. So this is a impulse. So I'm going to equate both of them. First, I have to find out the change in the momentum of the second block. To find out the change in the momentum of the second block, I need the final velocity, because the mass of the B block, final velocity of the B block minus mass of the B block and the initial velocity of the B block, correct? So let me write it BB also. This is the case. and then I'm going to equate to the force and dt value. So now I need the final velocity of the B block because they stick together. So whatever the final velocity of the B will be after stick together. So I'm going to apply the conservation of momentum. So let's write the expression. Initial momentum before the collision, P initial is equal to P final after the collision. Initial momentum is this one, plus of the second block is this one. This is minus, sorry, this is minus sign. I have to take care of the minus sign also. After they stick together, so the momentum will be, the mass will be after they stick together 6m m. So it becomes 7m, and the final velocity I have to be find out. So this is minus 4m v naught is equal to 7m final velocity. So the mm get cancelled out. So the final velocity just come out to be negative 4 v naught by 7. So this is the final velocity of the combined system. Whatever in the combined system, the B is going to be also have the same velocity, whatever the combined system it have. So the B is also going to be moved with that much velocity only. So let's plug in the values. So we have the here. So minus 4 by 7 mp is equal to minus 4 by 7 of the V naught, and the mass of this one is 6 m, and maximum is the constant, so that is going to become a constant. And we have the integration of the sign is minus cos at divided with the a also. You must know the substitution. You can apply the substitution method also. You can put it u, and then you will get this expression only. Then we have the 0 to tc, the maximum. Let's plug in the value. Upper limit minus plus. So this is cos 0 1. So this is come out to be basically getting. So this is the constant value. Okay. This is the a I can take it from outside of that, and then I can to find out the maximum value also. So basically, this is the maximum force that they ask for to calculate. So this is the maximum force that we will get that. So if you still have the doubt, please let me know. So you might struggle to do the integration. Please go through that again. Now we have the next part of the question is, consider the new scenario, and the block A is initially sliding in the positive x direction, and a new block of the block 1 initially that is moving, block 1 A block that is moving with the v1 velocity, and that has the same mass m. And the second block initially that is sliding in the negative x direction, but this is 6m, and that is moving in this direction with the v naught. Okay, and they get stick together again. And the new scenario, the two blocks have the constant velocity v naught. So they get stick together. So I'm just considering they get stick together. So this is m, this is 6m, and they start moving now we have to be, this is not possible because otherwise the momentum is not, doesn't remain conserved, because this have the momentum is 6m v naught, and this have the momentum is 7 v naught in this direction. This block is moving in this direction, so this scenario is not possible. So you have to be change the velocity direction. So you have to be considered this is the v naught. So now the momentum is for this one is they are asking the drive the expression for the v1 in the term of v naught. So let's the fundamental principle is conservation of the momentum that we are going to be applied. So this is mass into velocity 1 plus this is minus 6m v naught is equal to 7m v naught that I'm going to apply that in this direction. So now we have the mv. On the other side, it becomes 13 mv naught. Would cancel out. The mv is the 13 v naught. So this is the velocity. The expression is the 13 v naught is the final. So if you have still you have the confusion and you the confusion, please let me know. I'm going to continue this series of the FRQs. Thank you. Have a good day.